Our second candidate is Celia Hermoso Díaz. Hi, welcome, Celia. So your thesis is about DC-DC converter for data center power supply. It was made under the supervision of Professor Drazen Dujic. How do you feel?
Good.
Good?
Thanks.
So you can come in the center.
Yeah, thank you.
So that everybody can see you. Mm-hmm. When you're ready, you wave at Maxime.
Okay,
Thanks. Thank you. Go on.
Data centers are consuming massive amounts of energy. When we ask ChatGPT a question, we are used to getting the answer in seconds. And while this might feel effortless on our side, it requires a significant computational power. But power isn't the problem. It's the efficiency. There's a large portion of energy entering the data center building that is lost in its distribution, never actually reaching the servers. Nowadays, the electrical distribution inside data centers uses alternating current, which is the same kind of distribution we have in our houses. But the computers inside the servers require direct current to run. This is the same kind of energy stored in batteries and the same kind of energy produced by solar panels. So this implies that with the current infrastructure, the energy traveling from the grid to the servers must be converted several times. Think of it as translating a sentence between two languages. Every time you translate, a little bit of meaning is lost. So inside data centers, every time we convert energy, a little bit of it turns into heat, so it is lost. But thanks to the advancements in power electronics, future data centers infrastructure will use all direct current distribution, where we can use directly solar panels to supply the servers, as well as batteries. And most importantly, we can skip some of these unnecessary translations. My thesis focuses on designing the server power supplies of the future direct current distribution of data centers. I specifically work on two directions. First, I use a method that turns on and off electricity at very fast speeds, but with perfect timing. Think of it as pushing a swing. If you push against the direction, it's hard. But if you wait until it reaches the highest point, and then you follow the direction, it's effortless. So the electronic circuits I design capture this effortless rhythm and allow power to flow without creating any friction or heat. And also, thanks to these fast switching speeds, I can use smaller components in my designs. So one of the bulkiest parts inside power supplies, the transformer, can be made using less copper and smaller magnetic cores. So shrinking down these parts achieves what we call power density. Power density is the ability to handle more power in the same amount of space. So data centers can scale up their computational capacity without the need of building new facilities. So by the end of my thesis, this technology is set to be integrated right here at the EPFL data center, and maybe in data centers globally. So the next time that you ask ChatGPT a question, it will consume less energy. Thank you.
Thank you. Well, Celia, it was Celia Hermoso Díaz.